Alright, so here we're going to solve 1.2.4 Circuit Calculations, question number 5. That question number might change from year to year, but that's what we're looking at. So we're looking at this circuit. We've got to figure out what total voltage, total resistance, and total current is. We look at it and it is a parallel circuit, so that's going to bring in some different formulas. Total voltage is, just on the left side of the circuit itself, 12 volts. Total resistance is the sum of the inverse of the resistance and the inverse of that. So we've got our resistance of 8.2 kiloohms, 6.8 kiloohms, 4.7 kiloohms. So we're going to take 1 divided by, and then in the whole denominator, its own set of parentheses, 1 over our 8200. Put the extra set of parentheses in there to keep everything in the denominator and each fraction separated. Don't really need those extra set of parentheses around 1 over 8200, but just for fun we will in that first one, and then you can see on the next one, since we don't need it, we'll add it in. 1 over the 6800, 1 over the 4700, close that bottom denominator out. Therefore, that total resistance is 2075. You will notice that total resistance is less than the resistance of any other single component. So overall resistance decreases in a parallel system as you add more in there. We're just going to round that up. We're just going to go with 2.1 kiloohms to keep it in with the sig figs for everything to the right. Both answers should be good. Pay attention to the question and what they're asking for. Total current, well, V equals IR, so the total current is going to equal total voltage divided by total resistance. So we're going to take our 12 volts, divide that by our total resistance. In a calculator, I got that answer previous save, so I just take it, divide it the wrong way, raise that to -1, that's that inverse of it. So now I've got the total current of 5 thousandths, or milliamps is a better way to talk about that current. So we move that decimal place 3 times. We've got 5.78 milliamps. So now we're looking back. We've got a parallel circuit. Inside that parallel circuit, voltage stays the same. So the voltage at each one of those resistors is 12 volts. So now we've got to find the current at each one of those 3 resistors. So same formula, V equals IR. So total current at each individual spot is equal to the voltage there divided by the resistance at that individual component. So what we're going to do for each individual resistor, take 12 divided by that resistor value. So 12 over our 8200. We're going to take 12 over our 6800. We're going to take 12 over our 4700. To save some time, we kind of zoom along and hurry up there. We've got 12 now divided by 4700. We've got 0.002. We'll move that decimal 3 times to kind of fit it right into our milliamps. We have our different laws. The sum of all of the individual component amps should equal to the total. So if we find and add up those 3 sets of milliamps at each resistor, we add those together, we should see that the total of those 3 is equal to the total for that whole system. So this plus that equals that, gives us our total. We know we did things right. We can check that off the list.